Welcome to day 12 of calculus, where we spend some time discussing instantaneous rates of change. On question 1, it's asking, given f of x is equal to x squared plus x squared minus 2 rather, will f prime of 2, will the derivative of f at 2, will the instantaneous rate of change of f at 2, those are all saying the same thing, be positive or negative. So you can get an idea if it's positive or negative simply by making a sketch of the graph. So what does x squared minus 2 look like? Well, it crosses the y-axis at -2, and it's going to go up like this. So we're looking at, will f prime of 2, so when x is 2, what is y? So f of 2 is going to be 2 squared minus 2, and that's going to be 4 minus 2, which is 2. So it's roughly going to be right about 2, roughly right about there. The instantaneous rate of change is the slope of the tangent line at that point, so it's the slope of this line. Is that slope positive or negative? Well, it's rising from left to right, so we expect f prime of 2 to be greater than 0, positive. Now, let's evaluate f prime of 2, and when it says evaluate, we need to do it exactly, not with a table, but by using algebra, and we're going to use the difference quotient, the limit definition of derivative, which is the limit as h goes to 0 of f of a plus h minus f of a over h. I recommend writing this down every single time, especially at the beginning, but really more than you think you need because it's really easy to write this down wrong. So write down the difference quotient and identify the a value. And in that case, it's going to be 2. So that's our a value. So what are we talking about now? The limit as h goes to 0 of f of 2 plus h minus f of 2 all over h. And we can't plug in 0. The whole point is we can't plug in 0 because we'd create a 0 in the denominator. Our function is, again, x squared minus 2. So as a side note, what is f of a plus h? Remember, that means we're doing this part right here. And instead of a, what did we write? We wrote 2. So it's f of 2 plus h. So we need to actually do that out, and that's the thing squared minus 2. Minus 2, and instead of x, it's now 2 plus h. So what's that going to be? 4 plus 2h plus 2h plus h squared, and then minus 2, because this part right here became that. Can we clean that up a little bit? Well, it's going to be 4 into minus 2 is 2. So you have h squared plus 4h, there's the 4h, plus 2. Okay, so that's what's going to be in the green right there. That's what's going to be in the green. Now what about here, f of 2? Well, we know that f of 2, we already did it before, but do it again. It's 2 squared minus 2, which is 2. So that is a 2. So now when we write out this limit, we end up with this. And now we notice that the 2's cancel, leaving us with the limit as h goes to 0 of h squared plus 4h over h. And now the magical thing happens that we were hoping. We can factor out from the top an h, so it's h times h plus 4 over h, and now we can cancel, and now we have the limit as h goes to 0 of h plus 4. Now, can we plug in 0 for h? We sure can. It's going to be 4. Is that greater than 0? Remember, we expected it to be positive. You know, that graph wasn't super accurate, but does it kind of look like the slope of that line is 4? Kinda. So visually it matches. It is positive. Let's do another as practice. We have a new function. We're doing the instantaneous rate of change at x equals -1. So we know that a is equal to -1. And as I said before, please write out the difference quotient as follows. And now carefully evaluate the function. So we're doing f of a plus h. Well, that's going to be -2 times a plus h squared plus a plus h. It's a little more complicated than before. We are plugging a plus h into the function right there. We do this out by first plugging in -1 for our a value. We plug that in. Careful with that -2, it stays out front. And you do it all out, and you will end up with -2h squared plus 5h minus 3. So that is this part right here. Nice. Now we need to do f of -1 because a is -1, and we need to figure out that one. So that's going to be -2 times -1 squared plus -1. Making a positive negative sign error is really easy on this one. So you end up with minus 3. So now we'll put it all together, and we have the limit as h goes to 0 in the green part, so that's going to be negative 2h squared plus 5h minus 3. And we're subtracting the blue part, minus negative 3, and it's all over h. We're looking for things to cancel away, and one of them does. Negative 3 minus negative 3, those are going to cancel. So what do you end up with? Oh, you end up with the limit as h goes to 0 of negative 2h squared plus 5h over h. And that magical thing happens where we can factor out an h from the numerator. Negative 2h plus 5 over h. And then we have that nice canceling that goes on right there, leaving us with the limit as h goes to 0 of negative 2h plus 5. Can we now plug in 0? We sure can. We end up with 5. So can the algebra be a little tough? Yes, but if you do it carefully, it's relatively straightforward. So let's take a look at this next one, which is given f of x is equal to 4x plus 8, evaluate each of these. Now, looking at the rate of change when x is 0, the rate of change when x is 1, and then the rate of change when x is 2. The key thing about a linear function, though, is that by definition, a linear function, the rate of change stays the same. So this, another way to say f prime of 0 is what's the slope of the tangent line when x is equal to 0? Well, what does this function look like? Well, that function is 4x plus 8. It's going to cross here at 8, and it's going to have a it's going to have a slope of 4. The slope of that is 4. Well, no matter where you are on here, no matter where you are on this function, what's the slope of the tangent line? Well, it's always going to be a slope of 4, because that is the slope of the line. So in this case, when you're at 0, what's the slope of the tangent line? 4. What's the slope of the tangent line when x is 1? 4. And what's the slope of the tangent line when x is 2? 4. Now you could do it out algebraically, but you don't have to. You can just say this is a linear function. By definition, the rate of change is the same everywhere. The instantaneous rate of change is the same everywhere. Let's pivot into logs. Now, you might not remember everything about logs, but we can apply the same rule. So if we have a function and we're trying to find the instantaneous rate of change at x equals a certain value, we use the same thing, which is the difference quotient. The limit as h goes to 0 of f of a plus h minus f of a all over h. The function in this case is log x. So what does this become when you write it out? It becomes this right here, because again, our a value is 10, so all we did was plug that in. When something you do need to remember if you're going to simplify this nicely is that log 10, if log has no base written in, the default base is 10. The default base of log is 10. And you might remember that log base a of a, if you're taking the log of the same base and of the same thing, is always equal to 1 because a to the first is equal to a. We'll talk more about logs in class and you can ask questions, but you need to remember your basic log rules. That is all to say that this right here is equal to 1. So when you simplify, you'll end up with this expression. You can try playing around with it, but there really is no good way to algebraically manipulate this so that the h cancels in the denominator and you can plug in 0. So if you're algebraically stuck, you are going to need to make a table of values centered around 0 because that's what we are attacking right there. We're approaching from left and right. And we're talking about our x value and our f of x value. What's a little bit to the left here? Well, negative 0.001. What's a little bit to the right? 0.001. And you can fill in the chart some more, but you need to find out what these values are right here. You need to find out what they are. Those a little bit to the left and a little bit to the right of 0. And when I say the function, I'm talking about this function right here. You can plug that into your calculator. You're going to let that thing right there equal y1, and then remember you're evaluating y1 with that parenthesis of negative 0.001. And then you also want to check to make sure it's very close on the other side, so 0.001. And that number in between should come out to be 0.0434, the average of those two numbers. So you can try that on your calculator. So let's do another one. Again, identify your a value. In this case, it's negative 2, and then write the difference quotient. So now you've written the difference quotient. Now you need to plug in a is equal to negative 2. Now you just need to be careful about how you evaluate this. So when you plug in negative 2 plus h into the function, so what is that going to become? Well, you're asking the question, what is f of negative 2 plus h? That's going to be 1 over negative 2 plus h. So this is the green part right there. And then you need to also ask yourself, what is f of negative 2? Well, f of negative 2, keeping track of all the negative signs, we have 1 over negative 2. So that's the blue part right there. So when you plug this in, you end up with the limit as h goes to 0 of 1 over negative 2 plus h minus negative a half all over h. You get this thing right there. Still can't plug in h yet. So let's start simplifying. So what does this look like? Well, if we simplify the top, you still have the limit of 1 over negative 2 plus h plus a half all over h. And now we want to clean this up. So let's multiply the top and bottom by 2 over 2, which we're allowed to do because that's a form of 1. So we have the limit as h goes to 0 of 2 over negative 2 plus h plus 2 over 2 all over 2h. Now let's multiply by negative 2 plus h over negative 2 plus h. Again, we can do that because it's a form of 1. So if we keep up with this, we still have the limit as h goes to 0. And now remember, this thing is getting multiplied into both of them, same as before. So we end up with this. So all I did there was I distributed this into this 2 into this 2. You get those two pieces right there. What's the nice thing that cancels now? Well, that cancels, and so does the 2. Turning your numerator into the following. A lot of stuff cancels, but the denominator stays the same. But now what cancels? Well, 2 minus 2 is there. So you end up with the limit as h goes to 0 of h over 2h times negative 2 plus h. So now when we cancel, we end up with the limit as h goes to 0 of 1 over 2 times negative 2 plus h. Now can we plug in h is 0? 0 for h? We absolutely can, and we end up with 1 over 2 times negative 2 plus 0, which is 1 over negative 4. So we just found that the instantaneous rate of change of this function right here, 1 over x at x equals negative 2, we found it to be negative 1 over 4. Now let's sketch the function and look for f of negative 2. If you sketch this, it ends up looking like this. So where's f of negative 2? Well, negative 2 is going to be right about here. And then if you draw the tangent line, get something that kind of looks like this. Now, is that tangent line slope positive or negative? Well, it's negative. And could it be around negative 1/4? Well, it really looks like the slope there is negative 1/4. Now, you could use a calculator to graph that more exact, but what this tells us is that this algebra that we did here, all this algebra, tells us that the slope of that line is indeed negative 1/4. Well, what is f of negative 2? Meaning when you plug in negative 2 into the function, what is that? So f of negative 2 is 1 over this. So this point right there, that point is actually negative 2 comma negative 1/2. So that's the point. And what's the instantaneous rate of change right there? It is negative 1/4. There's the slope and there's a point. So what's the equation of the tangent line? This last question right here. The equation of the tangent line at x equals negative 2. To write the equation of a line, you need two things, a point and a slope. Well, we have both of them. The point is negative 2 comma negative 1/2, and the slope is negative 1/4. The one thing you need to remember is that I don't really want you to write things in slope-intercept form. I want you to write them in point-slope form. So that's y minus y1 is equal to m times x minus x1. That is super key because if you have a slope and a point, you're done. So in this case, y1 goes right there, x1 goes right there, and the slope goes right there. So all you end up with is y minus negative 1/2 equals negative 1/4 times x minus negative 2. Lots of negatives in there. You can clean it up a little bit. So you get y plus 1/2 equals negative 1/4 x plus 2. And you can stop there. You do not need to convert that to slope-intercept form. That would be the equation of the tangent line. Again, you just need a point and a slope. So I just went ahead and graphed both 1 over x and the function we came up with on a calculator, and look what it looks like. So again, what you see there is what the calculator would give you. So this part right here, that is, and this part right here, that's the function 1 over x right there. And then the tangent line is this line right here. So I plug both into my calculator, and does it look like it touches right in the one place we want it to? Yeah, it touches right about there, which is at the point -2, -1/2. Again, to write the equation of a line, all you need is a point and a slope, and this formula, y minus y1 is equal to m times x minus x1.